Welcome to EWC Controls. Today's zoning short take is on EWC's Smart Bypass Damper, also known as our SBD. If we looked at a typical duct system where we have 750 CFM heading to a living area and then 450 CFM heading to a sleeping area, when we shut off that 750 CFM zone, we don't expect to push all 1200 CFM down a 400 CFM duct. What we will install will be a bypass. EWC has 3 of them, but the one today we're going to talk about is going to be our SBD, and as far as I'm concerned, it will be the only bypass you'll want to install. According to our ACA manual ZR, the way we're going to set up our bypass is if we looked at the old school design for bypass and how we sized, we would basically take a 4-ton unit, let's say is blowing 1600 CFM, and we would look at our zones, separate them out. In a CFM, we have 1200 in one zone, 400 in another zone. We would size our bypass for basically the largest zone, hope that we can tie our bypass in 6 feet away and then just basically run it for the best. If I looked at a horizontal application, we would mount our bypasses right in the middle of the bypass duct over the top of the unit. And what would happen when all zones were calling, theoretically, this bypass would be closed and air would be stagnant on the front part of the bypass duct. If we're in areas next to the coast, this duct tended to sweat. Also, if we looked at the bypass duct, we have a double static. You have a supply push and a return pull. When a zone damper goes closed, the bypass starts to open up. All of our equipment now is variable speed, so variable speed runs on back pressure or resistance against the blower wheel. As soon as this bypass opened up, the static in the supply plenum drops. Well, how does our air handler react, or our variable speed blower? It ramps up. Well, as it ramps up, our bypass damper opens up more to relieve the air. As it relieves the air, the variable speed ramps up. And now the variable speed blower and the bypass fight each other. Plus, on the backside where this bypass damper ties in, this air is now flying through the bypass, going across the plenum, bouncing on the bottom, coming back up, and then pulling through the air handler. What happened right here? Well, that bypass duct now became an air curtain inside the plenum, blocking return air. How does the air handler then make up for air? Well, it starts to suck the bypass open. If you remember the old school bypasses, the arm and the weights, I would have guys calling me up asking for extra weights, or I have even seen duct strap tied to those arms, preventing the bypass from opening up. If we looked at a vertical application, the bypass on a vertical system, that air would be howling through here, but the same air curtain takes place. That air bounces all the way across the return plenum, preventing that return air from getting to the equipment. The way we're going to set them up now is we're going to take our bypass, we're going to install them right on the supply plenum. So when the bypass is closed, all the air stays in the supply plenum. Where the bypass is tied in on the return, we're going to install either a hand damper or a start collar that has a manual damper. Our return ducts will be mounted in front or tied into the return plenum in front of the bypass duct. Now we need to balance that bypass duct. If you do not balance it, more air will move through that bypass than what was designed. So what we're going to do is create static. How much static? Let's take a look. If we set up our system, have all zones calling, if it's a 2-stage piece of equipment, make sure it's up in high speed. Our bypass damper will be closed. Our hand damper or start collar with the damper in it will be closed. We take our dual port manometer and we're measuring our static across the equipment. In this application, we have a 0.52. Remember that number, whatever you come up with. Then what we will do is have only the smallest zone calling, have the other zones closed, take the bypass, make it wide open, go to the hand damper or start collar with the damper and slowly open it up. As we slowly open it up, we're monitoring our manometer, and until we reach that exact same 0.52 that we had with all zones calling, once we've equaled that same number, tighten this hand damper or start collar damper down. You're set. This bypass duct is now balanced. The variable speed blower has no idea that there's even zoning on the equipment. We will then release the bypass damper and then push as much air into the smallest zone without it being noisy. Now, what would happen if I could give you a bypass damper that was self-balancing? That's exactly what EWC has done. We've built what we call a smart bypass damper, where we have a Magna-Hela gauge basically built right into our motor. Comes with 2 pitot tubes where you tie into the motor, and you'll put 1 pitot tube into the supply and 1 pitot into the return. This is the industry's only bypass solution that will automatically measure, monitor, and maintain designed operating static pressure of the HVAC system in all modes. And how does it do it? With the simple push of a button. What we'll do is we'll have all zones calling. And again, if it's a 2-stage piece of equipment, make sure that unit's up in high speed. Once this has 24 volts put to this motor, 2 LEDs will light up. The power LED will light up, and this bypass setup LED will be blinking. It's letting you know that, hey, I'm ready to be set up. At that moment, we're going to take our thermostat screwdriver and we're going to press this bypass setup. It is actually a button. Press that button. Now that bypass setup LED remains constant. This damper will then drive itself to the closed position. Remember, all zones are calling. We have a pitot in the supply, a pitot in the return. In the return, once the bypass damper is closed, it'll sit there for 10 seconds, measuring the static across your system. It puts it to memory. It then opens the bypass damper all the way, sits there for 10 seconds, measures the static across your equipment. It knows the range at which it can now play. At that moment, this bypass setup LED goes out. It is set. Now, no matter what mode we are in, whether it's heating, cooling, low speed, high speed, fan, any zoning configuration that's going on, this bypass damper will maintain your static across your equipment. Now that hand damper or start collar with the damper, with the SBD bypass, notice we have baffles on each side of the blade. This hand damper is no longer necessary. We are able to create a pressure drop across that blade, holding the static constant, sending that static back to that variable speed motor, making sure that it doesn't hunt. Unless you're in California. California Title 24 does require that hand damper or start collar with the damper on it. Bypass sizing, well, that's time for another training class. You can visit your iPhone or Android app store, search EWC controls. At that moment, you'll see our app come up. Once you download our app, it is the front page of the app. It is a bypass calculator. This will calculate your bypass and it will let you know exactly what bypass is needed for your situation. I want to thank you for your time here today, learning more about EWC control, and I look forward to the future for more EWC zoning short takes on whether it's our dampers or our complete set of universal panels, as well as communicating panels, our fresh air panel, as well as you can look at our website, ewccontrols.com, and see exactly how we interact with these major manufacturers. My name is David Emig. I really do appreciate your time today. With EWC, we are here to help at all times. Please get a hold of our technical help department. They are open from 8 in the morning till 5 o'clock in the afternoon Eastern Standard Time. at 800-446-3110. Otherwise, if you have questions, feel free to email at sales@EWC Controls. Thank you. Enjoy the day.